Hello students, welcome back. So now we are going to be focusing our attention on stacking, which is part of ensemble learning. Ensemble learning, it means like you're training multiple models and you're combining their prediction. So the general idea for stacking is this. You train multiple base models. So for example, suppose you have a data like this. You have x1, x2, x3, x4. These are your features. And y is your target right here. So you feed this data to your base model. And your base model could be, for example, it could be logistic regression, and it could be decision tree, and it could be KNN. So you have three base models over here. They're going to make their own prediction. So let's say logistic regression makes a prediction right here. This would be a column for logistic regression. Your decision tree, it makes its prediction, so this would be that column, and then KNN, it makes its own prediction. That would be this column right here. Now this data, it gets fed to one final model. That would be your call meta model. So this random forest, let's say I'm picking random forest, this is my meta model. Now this model gets trained on this data set now, and this is the general idea of your stacking. Now, a few things I want to mention. The base model, it should be diverse. It should not be similar. So these models, they should be very different from each other. For example, this is logistic regression. This is a decision tree. This is KNN. And all these three models, they should be very different from each other. The second part is that the meta model, it never sees the original feature X. So if this is my X right here, your meta model is never going to see this X directly. What it sees is the prediction of this model, of the base model. That's what your meta model sees. The meta model, although it does see the prediction Y, so this is my original right here. This meta model is going to see that. So this Y is exactly same as this Y. So we perform cross validation when we feed our data to the base model, and that's because we want to prevent overfitting. Suppose we perform four-fold cross validation. So in this case, we have data right here, and I split into four parts. So I have 2, 3, 4, that will be my training part, and the part 1, that will be my testing. In the next fold, my part 1, part 3, and part 4, that would be training, and part 2 would be for testing. And for the fold 3, your 1 and 2 would be training, and sorry, 1, 2, and 4 would be for training, and 3 would be for testing. And in fold 5, my training would be 1, 2, 3, and the part 4 would be for testing. So these are my four folds. So the process for one base model, suppose it is logistic regression, would be like this. You train on these folds and you predict on the remaining fold. In other words, you train on this one and you try to make a prediction on these folds right here. And then you repeat this process for all fold on this one base model. So the result is this: every row will get a prediction from a model that did not train on it. So this way your meta model, it does not overfit. So suppose I do like this with this four-fold cross validation, and I get a prediction something like this. So we repeat this process for all the base model, and then we feed the result to the meta model. So suppose this is my result from the logistic regression. This is the result for the decision tree, and this is the result from the KNN. And this is my original Y. So I got this result, and then I feed this to my meta model right here, and the meta model now gets trained. So now suppose our model is trained and we get some new data. That would be this right here, and we want to make prediction. What we do is we feed this data to our base model. We follow the same process. The base model is going to make a prediction. So let's say logistic regression makes a prediction 1, your decision tree makes a prediction 5, and your KNN makes a prediction 7. So now this prediction is going to go to your random forest, and random forest now is going to make a prediction whether it is 0 or 1. So this is the process with this stacking. Now I will show you how to do stacking in Python scikit-learn library. So from scikit-learn, I'm importing load breast cancer. This is the data set I'll be using. I'm also importing train test split. This is going to be responsible for splitting your data into testing and training. I'm importing stacking classifier. This is the one that's going to be responsible for doing all your stacking. Then I'm importing logistic regression, decision tree classifier, k-neighbor classifier, and also accuracy score. Okay, so first thing I'm doing, I'm loading my data set right here. I'm splitting my data into training and testing. My testing size is 20%. I'm defining my base model. My base model is logistic regression, decision tree, and k nearest neighbor, KNN, which is in this case is called k neighbors classifier. So these are my base model right here. Then I'm defining my meta model. My meta model in this case is logistic regression. Then I'm creating my stacking classifier. So in my stacking classifier, I'm specifying my estimator. That would be my base models. I'm specifying my final estimator. That is my meta model. I'm specifying your cross validation. In this case, I'm using five-fold cross validation. Specify your stack method. In this case, I'm saying predict probability. So the meta model is going to see the probabilities. Pass through equal to false. What it means is that your meta model sees only the predictions. Okay, then I train the model. So I'm training my stack model right here, and then asking it to make a prediction. I'm feeding the X test data set. It's going to make a prediction, and after it makes a prediction, I'm testing the predicted value against the actual value, the Y test, and it's printing out the accuracy. And the accuracy comes out to be 95.6%.